Hi and good day everyone. Alright, so for the next video, I will continue discuss on methods of averages. Okay, so for method of averages, there are actually three models. Okay, average forecast, average change models, and average percent change models. Okay, so let's have a look at the mathematical equation. Okay, for these three models. Okay, method of averages. Right. Okay, so for method of averages, we will use its arithmetic mean, okay, as the forecast value. Okay, so the formula is the same as okay, when we average the observation, okay, and over the n, okay, over the how many observation in the time series. Okay, so this method is actually assume forecast value equals to the average value of the data series, right? And the method perform well if there is no discernible pattern, significant drop or growth. It means that our time series only fluctuate around the average value, okay, without any significant pattern or growth or drop. Okay, right. So again, okay, compares to time series that have uh, 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 that have extreme fluctuation, it is a method of averages might seems not appropriate to be performed. Okay, so let's take a look at how we generate uh, how we generate okay the first members of average models. Okay, average. Okay, just use the observation. This the average of. Okay, the average of. Okay, the average. Average. Okay, so 61. Value, this value. Okay, so this is a method of average. Alright. So if you want to calculate the error, actual, okay, actual minus fitted, okay, and this is the error for your average models. So that's the first member of method of averages, and we have the next models, average change models. Okay, average change model. Okay, for average change models, okay, it is more common use rather than the average method, okay, because of its stability and predictability. Okay, as we can see here, its mathematical equation is when you want to forecast one step ahead, ft plus m, as example, okay, the value is yt plus average of changes. Okay, but again, you have to take a look at the equation here. Okay, average of changes, what is the equation? Okay, as we can see here, the period of the observation is very important, since that for average of changes you need at least yt minus 1 and yt minus 2. Okay, suppose that you want to start at example 1961. Okay, so you need 1960. Okay, because 1961 is the one step forecast value. 1960, 1969, so you cannot start here because of what? Because you don't have observation at 1969. What about if you want to start at 1962? You will need here 1961, okay, 1960 and 1969. Again, you cannot start from here. Okay, that's why for one step ahead, okay, you can only start uh, based on our dataset example, you can only start at year 1963. Okay, so the forecast, the fitted value for 1963 is actually, okay, 1962, okay, 1962 plus, okay, plus, okay, 1962 minus 1961 plus, okay, 1961, careful 1961 minus 1960, okay, careful, okay, right, okay, over 2. Alright, so this is our forecast value. Okay, so since that we can use FT plus M, so you can generate one step ahead forecast. Okay, so for 1998, again you can calculate the error. Okay, and the error is the actual value minus the fitted value. Okay, and then you drag up until here. Okay, alright, so now let's take a look at here. Okay, so now as example here, okay, as example here, this is how we generate the fitted value for average and average change model. Okay, suppose that we use the same approach with naive models. Okay, we use the first 30 observation here as the estimation part. Okay, as the estimation part, and the last 8 observation as the evaluation part. Now your job is to determine, okay, which model is the best by using MSE. Okay, so for MSE, okay, evaluate estimation part, and we will have evaluation part. Okay, you will have sum SE, how many N, and we will get the MSE. Okay, the same for, okay, so here square error, okay, so okay, same goes here, square error. Okay, so this is our last observation. Okay, like I mentioned before this, before we do one step ahead forecast for unavailable data, make sure that you compare first, okay, which model is the best by looking at which error have minimal MSE. Okay, so for this part, the sum SE is equals to sum, okay, here up until here. Okay, for evaluation part is, okay, sum, here up until here, the last observation, right? Okay, how many n? Okay, so there is no closing observation, and here is 30 and here is 8. Okay, so this is average model, and then this is for average change model. Okay, so for average change model, estimation is equals to sum, okay, error square, right, estimation up until this part only, evaluation is equals to sum, okay, from this up until the last observation. Okay, so n here, since that 30 minus 1 2 3, so 27. Okay, n is 8. Alright, so now you can calculate MSE. Okay, sum of SE over n, okay, same goes here. Right, okay. Right, so based on these two models, which is the best? Okay, especially when we compare evaluation part here, we can see that average change model provide us with the smallest MSE. So for this purpose of example, I will say average change model is better to be used as forecast models compared to average models. Okay, the first average models. Okay, alright, so that's example based on average change models. Okay, so basically we compare the MSE based on the evaluation part. Okay, depending on the purpose of our models. Okay, so that's example. Okay, now I will leave one more models here. Okay, we have one more models here, which is average percent change models, and I will leave this as your exercise for the second part. Alright, okay, I think that's all for the second video. Okay, thank you for listening. Bye.